Hi there, in this video, we'll continue learning bit instructions. We'll learn latch and unlatch outputs. And also one-shot rising and falling instructions, then we'll see some basic logic, and finally we'll do a simple project. Before we get started with today's video, I just wanted to inform you about all the great content I have been releasing on the PLC Goods YouTube channel, which includes industrial automation PLC programming, HMI and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Alright, let's start with latch and unlatch instructions. In the PLC wiring, 4 push buttons are connected to digital inputs, but only 3 of them have been used in this program. Like industrial circuits, supposed here we have a virtual voltage. The first line has been explained in the previous video. The first output will be off, unless the first digital input is activated by the first push button. In the second line, a latch instruction has been used. This instruction only used to turn on outputs. So, based on this program, if I press the third push button, the second output will be on, and if I release the push button, the output remains on. In the last line, an unlatch instruction has been used which only used to turn off outputs. So, if I activate this contact, the second output will be off, and if I release that, it remains off. Pay attention, you can recognize latch and unlatch instruction by the letters L and U. Now, let's test this program. It's expected you can write this program. Otherwise please see previous videos. Then you can insert latch and unlatch output instructions like me. Now I use the second output for the latch and unlatch instruction. Now, let's compile the program, and then, transfer it to my processor. Let me change the processor mode to run mode. As you see, in the first line, based on the state of the first digital input, the green lamp which is connected to the first digital output, will be on or off. Based on the second line, the next push button only turns on the red lamp. When I release that, the red lamp remains on. And based on the last line, the next push button only turns off the red lamp. As you see, if I press the last push button again, the red lamp will remains off. Now, let's tell you another point. Sometimes, for maintenance purposes, or when a connected switch or sensor is broken, we can activate digital inputs with our connected computer. For example, let me right-click on this digital input address and select Force On. As you see, the green lamp is turned on, like when I used the first switch. Naturally, this way can change the input voltage on digital input terminals, but it can change the input image memory, which has been explained before. Well, let me use Force On to activate the second and third lines. In the second line, my processor turns on the red lamp, but at the next line, changes its decision and turns it off. So, if an output address has been changed in several lines, the last one will be used to update real outputs. Also, when we're using force ability, the message, forces installed, will appear, and also the force LED on the processor will be on. Alright, let's continue this video with other bit instructions. One shot rising and falling. This program is similar to the previous program, with the same wiring. So, one of the advantages of using PLCs is the ability to change the control logic without changing the wiring. As you see, latch and unlatch instructions have been used, but a one-shoot instruction has been inserted in the second line. So, if this contact is activated, then the virtual power will change from 0 to 1 behind the one-shot instruction. After that, we'll have one pulse at the output of this instruction which can turn the green lamp with latch instruction. Pay attention, the one-shot instruction is not sensitive to the state of virtual power. Let's test the program. I have inserted two normally open contacts and unlatch and latch instructions which have been explained before. Now, let's add a one-shot instruction to the second line. This instruction needs a bit of memory to work correctly. Here, you can use a bit of binary memory, like output image memory. But binary memory won't waste my physical output, and also, I do not have a limit on its number, such as the number of physical inputs and outputs. Well, let's use the first bit of binary memory. Okay, let's test the program. My processor is in program mode, let's change it to run mode. Well, based on the second line of the program, let's turn on the green lamp with the second switch. Now, based on the first line, let's turn off the green lamp. The second switch is still activated, but the output is off. Because, as we said before, the one-shot instruction in the second line, only sensitive to change in virtual power. So, to turn on the green lamp again, I must inactive, and then activate the second digital input. Alright, we have seen how one-shot instruction works. If we need to use the state in another line of our program, the one-shot rising instruction can be used. This instruction needs two bits. One bit to storage virtual power state, like one-shot instruction, and the output bit, which can be used in other lines. Similarly, one-shot falling instruction can be used to detect negative signal etch. So, at this time, we'll have a pulse at this bit. Pay attention, if these instructions are used simultaneously in one program, their storage bits must be different together. Alright, let's rewrite the previous program, with one-shot rising instruction. Here, I use bit number 3 of my binary memory, and then I will use that in the next line, to turn on the output. Well, this and the previous program are equal. Try to test it. Similarly, you can insert and use one-shot falling, from here. Alright, until now, we have explained some basic bit instructions. Now, you can write and test basic logics such as AND, OR, and exclusive OR. For example, in the first program, the output will be turned on if and only if both digital inputs are activated. Try to test and explain these basic logics. Now, let's do a simple project. See these three conveyors which are physically hooked up in a series configuration, where conveyor number 1 feeds parts to conveyor number 2, and conveyor number 2 feeds parts to conveyor number 3. Each conveyor should have its own individual start-stop station at that conveyor. There will be one emergency stop push button placed strategically to stop all three conveyors. Conveyor 3 must be running to start conveyor 2 and conveyor 2 must be running to start conveyor 1. This wiring can be used for this project. The first digital input is considered for emergency input. S2 and S3 push buttons are used to stop-start conveyor number 1. Similarly, S4 and S5 are used for conveyor number 2. And the next switches are considered for conveyor number 3. Also, we need 3 contactors. Each contactor can turn a 3-phase motor with a power circuit like this. Now, try to write your program and test it. This is my program. As you see, the emergency input has been used in each line. This part of the program has been used to start-stop each motor, which has been explained before. Note that, to turn on the second output, this normally open contact must be activated, which its address is referred to third output. So, to turn on the second motor, the third motor must have been turned on. Similarly, the second output must be on, to turn on the first output. Alright, let's test the program. As you see, I cannot turn on the first output, by pressing its related start push button. Because this contact of the second output is still inactive and open. Similarly, I cannot turn on the second output. Because the third output is off, and this contact is still open. But I can activate the third output. As you see, its related LED on my processor has been turned on. Now, I can turn on the second, and after that the first output. Also, each output has its individual stop push button, but if I turn off the third output, other outputs will be turned off too. In the next video, we'll see what are timer's instructions. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.